Stage 3 of model-based inquiry is called negotiating ideas and evidence through tasks. This stage makes up the majority of the unit. It is where students take the ideas they generated in Stage 2 and begin to test, revise, and extend them using purposeful tasks that generate meaningful evidence. Stage 3 is not a single moment but a cycle. Students are introduced to new ideas, investigate and test them through data-rich tasks, and then later revise their models based on what they have learned across several tasks. Model revision does not happen after every task. Instead, students typically pause midway through Stage 3 to revise their models in light of the accumulated evidence. Each task becomes an opportunity to work on and develop important science ideas that will inform that mid-unit model revision. The goal of Stage 3 is to support ongoing changes in students' thinking by creating learning experiences that help them coordinate their own ideas with powerful ideas in science.
Not used in the operation of the toy, you don't have to list it.
But what if you use it like that?
So if you use it and you're like, yeah, I'm slingshotting this off the table, right? Then you do have some gravitational, which then also gets converted to more what?
To more translational.
More translational, more movement.
Teachers select or design tasks that align with the important science ideas identified back in Stage 1, and students use these tasks to generate evidence they can use to revise their models. This ongoing cycle, introducing new ideas, investigating through tasks, and revising models later, builds a deeper scientific explanation of the anchoring phenomenon. Stage 3 is directly shaped by the work done in Stage 2. In Stage 2, we elicited as many ideas as possible and treated those ideas as resources, not misconceptions to fix, but starting points for investigation. Stage 3 uses those ideas to determine which tasks the class needs. In Stage 3, the class begins systematically working on those ideas through purposeful, evidence-generating tasks. Every task in Stage 3 follows the same general pattern. First, the teacher introduces ideas that may come from students' initial thinking in Stage 2, or may be newly introduced because students have not yet considered them. Ideas that require clarification, expansion, or testing. Second, students engage in a purposeful investigation. These tasks generate evidence that helps students evaluate their earlier ideas. This cycle repeats for each major task. A typical unit might have 4 to 6 cycles, each building toward a more powerful explanation. Third, students revise their models midway through the sequence of tasks, once they have enough evidence to meaningfully update their explanations. In the Hindenburg unit, an early Stage 3 task is the Exploring Energy Lab. The purpose of this lab is to help students develop a foundational idea. Systems can store energy in different forms, and that energy can be transferred or released rapidly. The teacher begins by introducing a science idea emerging from student models: how energy stored in chemical bonds can be released when substances react. Students then investigate through hands-on experiences and data collection, examining how energy changes in physical and chemical processes. Students document observations, compare mechanisms, and begin to reason about how a spark could release stored chemical energy in hydrogen. After several tasks, they will return later to revise their models with this evidence. A later part of this task challenges students to use representations, such as energy bar charts, to show how energy moves and transforms. These representations strengthen their ability to explain why the Hindenburg burned so quickly. In the Lampsilis Muscle Evolution Unit, a central Stage 3 task is the I Will Survive lab. Before the lab begins, teachers introduce an idea emerging from student models, the role of variation in survival and reproduction. In this task, students analyze evidence about the muscle life cycle, examine differences in lure traits, and evaluate how those traits affect the likelihood of attracting a host fish. They might sort images of lure types, interpret data on larval attachment success, or simulate how selective pressures increase the frequency of certain traits over generations. This evidence helps students revisit their initial explanations later, replacing early anthropomorphic ideas with a mechanistic understanding based on natural selection. Their mid-unit model revisions reflect these new insights. The summary table is the most important public record in Stage 3. It is used after each task to capture what was learned and how that new learning helps explain the anchoring phenomenon. After every investigation, students add evidence, emerging ideas, and connections to the phenomenon, building a shared and evolving record of sense-making. The goal of the summary table is to help the class keep track of how each task contributes to their understanding. Because students return to it continually, even at unexpected moments, it stays visible throughout the entire unit. Over time, the summary table becomes an essential tool for comparison, pattern finding, and coherence building, and it provides the key evidence students will draw on when they construct final explanations at the end of the unit. Stage 3 is where students engage most deeply in the practices of science. They test ideas, analyze evidence, and revise their models as a class midway through the sequence of tasks. Through purposeful tasks, students learn to coordinate their own thinking with powerful disciplinary ideas. By the end of Stage 3, students have generated the evidence needed to construct a well-supported explanation of the phenomenon. They are now ready for Stage 4, where the class begins the work of building consensus. Negotiating ideas and evidence through tasks is the engine of model-based inquiry. It transforms the raw ideas from Stage 2 into evidence-based explanations. To explore more examples or access MBI curriculum resources and tools, visit modelbasedinquiry.com.